Northwest Tank Calibration.
Before parking the vehicle at a dispenser, the technician begins to block off the selected pump after customers are done pumping their fuel. Remember, the site customers have their own schedule and do not want to be delayed or inconvenienced. Directing them to the next available pump with a smile always helps the situation. When selecting the position to park the vehicle for meter calibration, the technician must make every attempt to choose one with the lowest impact on customer business. If safe to do so, always park facing away from the dispenser to not block the next dispenser, which will allow customers to use that pump. Set up traffic control to prevent vehicles and people from entering the work area on both sides of the dispenser. Construction netting must be used. The only exception is under extreme high wind conditions, in which case caution tape may be set up between delineators. In order to deliver a consistent service, the measuring provers must be leveled carefully each time the vehicle is moved. This step is essential for accurate readings. The level indicator attached to the prover is used as the primary level check. A portable handheld level is used as a backup to make absolutely sure each prover is level before measuring the fuel. Another detail critical to accurate readings is consistent drain times. The provers are calibrated at the metrology lab based off of 30-second drain time. Therefore, it is required that the fuel drain is carefully timed for 30 seconds after each test using a digital timer. Before the first calibration, a wetting down of the provers must be performed. This allows for the accurate drain time before calibrating any meters. After the provers have been verified level and each one have been drained for 30 seconds, the equipment is ready for measuring product. Once the dispenser is placed in standalone or has been authorized by the cashier, the dispenser is ready for the first measure test. The display will start at 0.000 gallons, and the technician will attempt to pump exactly 5 gallons in what is known as fast flow. An accurate dispenser will display exactly 5.000 gallons, and the fuel level will be exactly at 0 on the sight glass of the prover. If the fuel level is not at 0 when reading the bottom of the meniscus, the dispenser did not pump exactly 5 gallons, and an adjustment will be required if the actual fuel pumped is off by more than 1 cubic inch above or below the 0 mark. In this example, the dispenser is displaying 5.000 gallons, and the sight glass on the prover indicates exactly 5 gallons by reading the fuel level at the bottom of the meniscus at the 0 cubic inches line. In another example, the measured product line falls 2 cubic inches short of the 5 gallon mark. This reading is recorded as a -2. All readings are recorded as cubic inches in relation to 5 gallons. Here are a few more examples of measured product not exactly 5 gallons. This example would be recorded as +3 cubic inches, while this one is at a +6.5 cubic inches. And this one is at a 2.5 cubic inches. Some meters are electronic, as this Wayne eye meter, for example. After removing the existing security seal and opening the eye meter plunger, the technician will pump exactly 5.000 gallons, effectively teaching or programming the meter to measure 5 gallons accurately. Some meters are mechanical, as with this Tokine meter. Mechanical meters have a dial which is adjustable by turning the dial left and right for the desired adjustment. Again, the technician removes the existing security seal, then moves the dial. The technician will then test the accuracy of the adjustment by pumping another 5 gallons. In accordance with NIST Handbook 44 guidelines, this process is repeated until the reading on the display is 5.000 gallons, and the reading on the prover is as close to zero as practicable. If the display does not read exactly 5.000 gallons, the technician can use known measurements to record the actual reading. 1 cubic inch equals 0.004 gallons. Therefore, if the dispenser displays 4.996, an accurate meter would measure -1 cubic inch on the prover. In another example, if the dispenser displays 5.008, an accurate meter would measure +2 cubic inches on the prover. This volume correction takes some practice, but does not take long to master. Once the meter has been adjusted to as close to zero as practicable, the technician is ready to test the slow flow of the meter. If the difference between slow flow and fast flow is more than 4 cubic inches, the meter is bad and should be flagged for replacement. Once calibration of the meter is complete, the technician must seal the meter in accordance with manufacturer and regulatory agency standards. The goal in sealing a meter properly is twofold. 1, to ensure the meter cannot be adjusted without breaking the seal. Only registered service agents are allowed to break a seal and adjust a meter. 2, identify who was the last registered service agent or agency to break the seal and adjust the meter. The seals must follow local regulations for proper identifying stamps. Some regulatory agencies require an additional method of identifying the registered service agent making the repairs. In some counties in California, for example, the technician must place a sticker on or near each meter which displays the full name of the service agent and agency, registered license numbers, and the date of the meter adjustment. Once the meter calibration, visual inspection, and proper sealing and tagging of the meters are complete on both sides of the dispenser, the technician is ready to move on to the next dispenser or return the fuel to the storage tanks. Before doing so, the technician must ensure the dispenser is no longer in standalone mode and check the area for loose tools or trash. Once these important steps are taken, the technician may remove the traffic control when it is safe to do so.